Hello. In this video, I'm going to explain classifying statements in propositional logic. Now, in order to classify statements, you have to first know how to build a truth table. So watch the video on how to build truth tables. After you build a truth table, you simply look at the column underneath the main operator. And if the column under the main operator has trues all the way down, it's called a tautology. If it has falses all the way down, it's called self-contradictory. And if there's at least one line where it's true and at least one line where it's false, it's contingent. So you can see the one that I worked out from the previous, or the two that I worked out from the previous video. This one happens to be true all the way down. So this is a tautology. This one has at least one line, actually it has three, where it's true, and at least one line where it's false. So this is contingent. What we mean by that is it depends on the truth value of the components. It's contingent on the truth value of the components as to whether or not the overall statement is true or false. But no matter what, here, this is always going to be true, no matter what K stands for. And we could create one that was always false. Let's see here. Let's try this one. Suppose you have this. K wedge T is equivalent to tilde in parentheses K horseshoe tilde T. Now, when you work this one out, okay, so let's start from the beginning here. Actually, I'm going to use this color. We have exactly two different letters. Now, each letter is used twice, but we have exactly two different letters. So 2 to the 2 is 4, so you have 4 lines. 1, 2, 3, 4. Next, underneath the first letter, the K, you do half trues, half falses. You do that same here, half true, half false. Then underneath the T, that's the second letter, you do 1/4 true, 1/4 false, 1/4 true, 1/4 false. Same over here. And then you just work it out, working from your parentheses, inside your parentheses, and working out. Now, I hope this actually ends up with a self-contradiction, but we'll see. Here you have T wedge T is T. T wedge F is T. F wedge T is T. F wedge F is F. Okay, so what I like to do is I like to put an X at the bottom of the columns that I've used, just to help me keep track of what's been used and what hasn't. I don't want to cross them out because it gets all messy and it's hard to double check yourself that way. But let's look over here at this one. So tilde T is F, tilde F is T. Tilde T is F, tilde F is T. Okay, that's been used. Now, what do we have for the horseshoe? Well, you have T horseshoe F is false, T horseshoe T is true, F horseshoe F is true, and F horseshoe T is true. Okay, this is not going to end up being self-contradictory, but whatever. So this has been used and this has been used. Now, tilde in front of this, because this is the main operator in the parentheses, so tilde F is T, tilde T is F, tilde T is F, tilde T is F. Now, comparing this column with this column to work out the triple bar, and I'm going to put that in pink here. We've got T triple bar T is T. T triple bar F is F. F triple bar T is F. F triple bar F is T. So there's your truth values underneath the triple bar. Now notice there's at least one true and at least one false, so it's contingent. If this had worked out false all the way down, now it didn't, but if it did work out as false all the way down, it'd be self-contradictory. If it worked out as true all the way down, okay, make a mess of this, but I'll do it anyway, then it would be a tautology. But that's all you have to do for these problems. If you have any questions, let me know. I'm going to go to the next video, which is categorizing pairs of statements. Thank you very much.